So for our next example, we're going to look at how to find the extrema of another quadratic polynomial in two variables, x squared plus 4y squared, on the parabola y equals x squared minus 2. Okay, so the first thing when sitting down to this one is to figure out what your constraint function is. And this is kind of not written in the right form. It's nice for recognizing it as a parabola, but what is it as a level curve? Well, it's actually y minus x squared being set equal to minus 2. Or, if you like, it's x squared minus y being set equal to 2. And since I have some unnatural disagreement with negative numbers, I'll just go for this one. So I'll take this to be my constraint function, x squared minus y. And so we're looking at the level curve, which is where g is equal to 2. All right, so now that I know what g is, I can take its gradient. So let's go ahead and do Lagrange multipliers. So we'll take the gradient of f, so that's 2x 8y, and then we'll take this we'll set this to be equal to lambda times the gradient of g, so that'll be 2x and minus 1. Okay, and so then that gives us the system 2x equals lambda 2x, and 8y is equal to minus lambda, and then we've got our constraint of x squared minus y equals 2. All right, and so what to do next? Well, from this first one, we can cancel the 2x's and we get that lambda is equal to 1. And so then substituting that into the next equation, we get 8y equals minus 1, so y equals minus 1/8. And then from the last one, we can back solve using the constraint equation to see that x is equal to plus or minus square root of 15 over 8. Okay, and so then that tells us where we have our maxima and minima at positive negative 15 root 15 over 8 minus 1 over 8. And so then just to confirm this, we can plot the picture. And here's what it looks like. And well, let's take a look at this. What happened? So the way, once again, I've got these numbered so that you can see the value. So this is the level curve right here where f takes the value 2. This is the level curve where it takes value 4, and so on and so forth. And you can see that the one right here where it's tangent and the one right here where it's tangent are the ones that we found. But that's not the right one. The right one is down here, because look at how much bigger f is at this point on the parabola. We got all the way up into the orange. These ones were back in the blue where f was taking paltry values. It looks like we should actually have some maximum value of f that looks like 11 or something like that, right? It's bigger than 10 anyways. So what went wrong? And I made this mistake because I wanted to illustrate it, because it is the most common mistake that people make when working with Lagrange multipliers. And I'll give you a moment to think about it and a moment to answer. And hopefully, I'm wildly optimistic that you all said, hey, it happened exactly right here when we divided both sides by 2x, because we've got no reason to believe that x is non-zero, and you can't divide by 0. And so we lost a solution x equals 0. And sure enough, going back to the picture, that situation corresponds to when x is equal to 0. All right, so I'll let you go back and recapture the missing solution, which is actually 0 minus 2. But that's your lesson for why you should be very careful. And actually, if you go back to the first clip that I did for 14.8, you will notice that when we were solving, so this is from 14.8.2, when we had the equation 2x equals lambda 2x, I did not solve this as 1 minus lambda by canceling. Instead, I rewrote it a different way. I subtracted this over to the other side. So it became 2x minus lambda 2x equals 0. And then from that, I could factor out 2x 1 minus lambda equals 0. And then, so you can see, if I do it the subtractive way as opposed to the division way, then I retain both the solution lambda equals 1, but also the solution x equals 0.